All right, so I think everything's good. I think we've got everything ready for Unit 7. I haven't streamed for a few days, so we're going to go ahead and just pop on and record this real quick, and then we'll get this one done. So this is Linux Security Engineering Unit 7 with the Professional Linux Users Group. My name is Scott Champagne. I'm the one who's been facilitating the courses for our group and kind of running through my experience in the field of securing Linux. So let's go ahead and get into this one. Here's our information. If you need anything, if you need to contact me, just go do that down in the Discord. That's the easiest way to get a hold of me. This is our 7th class, and then this is our reminder that we are doing a big event, the 8th, the 9th, and the 10th down in Discord. Last year we had a few hundred people come to it over the few days. We have guest speakers that come. We have all kinds of fun stuff. It's all free. You can come and hang out and just, do whatever you want. So, all right, so that's something to always mention for you guys. Last week, what did we do last week? We talked about storing logs, where we put them. We talked about parsing logs. We talked about all these things that logs entail, like what are they? We did a worksheet and labs like normal, and I think this was the topic outline. What is a log? It's an immutable record of an action that occurred or tried to occur in the system, right? Even things that didn't occur still have to be logged, especially if they're security event type things, right? Then we talked a little bit about how we use logs and what are some common log elements. We talked about the RFCs that govern either the old BSD or the newer IETF standards for logs and what they have in them. We talked about the structure, because if we're going to be parsing or chewing things up later and pulling out relevant information, we should know certain things like the time and the server and the process, and then a short little description. So we walked through all of these things, right? And then if we're going to be in the business of doing all those things with logs, we've got to think about where we store them. They're these persistent, immutable actions that are always being tracked. So what do we do? If we have a centralized location on a server, we need to rotate them for space and compression and make sure that we're not using up all the space in the server doing useful things with recording those useful things. That would also be problematic. And then this is probably maybe the most important thing that I talked about, is you have to get logs off the servers in real time. You're doing all these other things, but if the logs are not in a usable place for your organization, they're not in a usable place when an incident occurs and takes a server or set of servers down, well, we can't even talk about if there's a security incident or not, because we don't even know. We don't even know what we don't know, because we can't get into logs until the servers come back up. We've got to get logs off servers in real time. It's one of the highest stigging requirements. You always have a stig requirement for it, and it's just good operational things to be able to work on a server. It's good operational practice to be able to work on a server when the server is not active. You've got the information, you know what happened, you can get the black box, if you will, off the server of what's important. And then we talked about how do we parse logs, specific information, parsing logs with command line tools on the machine, which we talked about how you're not ever really doing it by hand. You're using cat and grep and awk and all these different tools to carve down and maybe look for patterns and stuff like that. And then we also talked about when we get to scale, right? When we get to multiple servers, we start to use specific tools like Splunk is a really good one. LogQL to query out of like Loki and other tools to get log information out are kind of very common. So that was the review from last week. This week, what we're talking about is monitoring. And monitoring entails all of that logging stuff, which is very important by itself, but it also expands out into a few other things. So what do we monitor? That's going to be one of our topics of discussion. And then how do we decide what to alert? So all these systems that we work on, right? Like let's say we're in a Linux environment and we've air-gapped it off like we've talked about, or even not in an air-gapped environment, just at your company. When you go home for the day, you are no longer part of that closed system. You are no longer logged in. You are no longer connected. So the idea of alerting is sending information out of a closed system. And how do we decide on what to alert? Should we just send everything? Well, there's that old story. It's like one of the oldest stories around of the boy who cried wolf. The boy kept yelling, and then when you really needed help, nobody came, right? It's the same idea here. Like, how do we decide on what to alert? It needs to be actionable. It needs to be timely and these kind of things. So we're going to talk about that a little bit. There's a worksheet and a whole bunch of labs that we're going to do for this. So, all right, let's get into it. What do we monitor? There's telemetry, which are metrics, and telemetry literally means metrics at a distance. So we track metrics about this stuff. We always track the big four. The big four are always important. That's compute, memory, disk, and network. And typically in that order. That's the order that we go in as engineers. Trace is a process as it flows through the system. So you've got a front end load balancer, and a query comes in, and it hits your front end load balancer, and then it goes back to your application server, and then from your application server it queries a database. That whole line of information running through your system is what we would call like trace data. That one query being followed through all those different servers. And then the last one is logging, but they're in no particular order here. And then logging is what we talked about heavily last week. So how do we monitor? Well, we set up infrastructure to catch logs off of the system. We're going to talk about that a little bit. And then as we hit thresholds and as we hit different, if we want to think of them almost as like lines in the sand, when we hit those, we are going to alert out. Typically, we have like a warning and a crit and those kind of things. And then we send messages outside of the system when those things are hit, right? And then how do we alert? We can send things to Alert Manager and Discord or Slack, or there's all kinds of things that Alert Manager can go out to, and then Grafana can go out to all kinds of different ones as well. I use Discord in my example here because that's what we're going to be using in the lab, so we're going to send it to our Discord. And then when do we alert? Do we go on a priority, like a severity, like there's warn and there's crit, and then also windows of time. So this should be really windows of time in that there are things that are critical alerts to me during the day when I'm at work, like the developers, 20 of the developer servers are down. Yeah, that means developers are going to be sitting on their hands not doing anything. That's a problem to my company. But on Sunday night, I shouldn't be getting that alert because the dev systems being down doesn't matter because the developers are also all asleep. Now, you might very astutely say, but what if our developers work in another country? That's common, so now the windows change, right? We understand what the windows are first, and then we move them to wherever we need them for applicability in my organization. And then if I can't stomach those alerts calling me out on Sunday night, then I need to think about, either the stability of my systems or the stability of my career if I want to stay with a company that has that window. But the company has to assign the windows, and then by extension, the engineering teams have to use those windows. So, all right. That's our overview of what we're talking about. Let's get into it. Intro to monitoring. What types of data do we monitor and why do we care? Well, we monitor logs. They're a record of what's happening within your system or software. We talked about how they're an immutable thing. Now, all kinds of tools and other stuff, and you'll see people like, well, then I'm just going to add this to it and I'm going to transform this and this. That's fine. Don't change the original log. The original log message is like carried like a little golden scepter all the way until it's placed down in its log. It is not changed. You can add other things and you can take pictures of it and do stuff like that with other, you can make events from the event if you want. You can make logs of the log if you want, but you don't change the original log, right? There's good reason for that. I mean, we don't want to go and look at things later and then see all these transformed bits and not know what are the actual original immutable things that happened. We need that's what we call replayability of events, right? Anyways, so then we have metrics. Metrics are assessment of our system, and typically the metrics that I want to know are the utilization, the saturation, and the error metrics. That's what we always talk about as administrators. That's the use methodology. Utilization is always a number between 0 and 100%. Saturation is weighting and queues and those kind of things. And then errors are error rates as things start to time out. Those are common things that we always check for in systems, right? From the admin all the way up to the engineer level. And then traces is how data are moving through our system. It also checkpoints the processes as data moves between the nodes. So we track how things are moving, again, between the different systems. And typically we need specialized software for that, or we need to just really be tracking what's going on within our system and our calls and those kind of things. So this is our intro. This is back to the administrator stuff. When we start having issues for resources, we check utilization, saturation, and errors. You will always hear me talk about the use methodology for administrative troubleshooting and just checking. Like if somebody says, how healthy is your system? Well, we check for utilization, saturation, and errors, and we can pretty well tell you if the system's going to continue on down the road for the rest of today, or if it's really getting saturated at certain times of the day, and then we're getting errors, and well, maybe the system's not fit for use anymore. Maybe it's not checking all the boxes of what it's supposed to do, right? So these are the kind of things that we look at from a systems administrator standpoint. This is not heavily the part of the system, the system admin role is not heavily what we're going into in this course. We're dealing more with what the security engineer cares about. And the security engineer is looking for what we call indicators of compromise. If we're monitoring things, we want to know, is the system performing out of normal operating ranges? Is something happening to our system that shouldn't be happening? Either internally on accident, or internally malicious, or externally, typically malicious from external. There's not really an external accident, I don't think. But I tell you guys all the time, does it matter why a system was compromised internally? If somebody accidentally left the door open, or if somebody accidentally did something else, does it really matter? It doesn't matter, does it? It's still gonna be a problem. So maybe you've got high CPU. Is Bitcoin mining occurring? Do we know how to track those kind of things? Do we know how to blacklist all the DNS that they typically go to and all of the ranges and those kind of things? Are there connections to outside locations that are not normally made? Is that an indicator of compromise of some type? Hold on real quick. I gotta turn this music down. Where's this thing at? Hold on. Apologize, guys. That music's just louder than I'm used to. Okay. So, and then user logins to multiple areas that they don't normally try to log into. So if a user gets compromised in some kind of way, typically the first thing the process does is start trying to password spray them all over the environment, see all the things that they can log into. And if we're tracking users logging in, it's called user behavior analysis, right? If we're tracking what users are doing, then we can see what's happening. But all of this stuff assumes that you have things in place to monitor, right? So we have to set up some of our monitoring. All right. So what are we monitoring? Well, there's these kind of SL type acronyms, and typically we need to know what our service level indicators are. What tells us that a system is at a certain level? Like, what tells us that a system is working? And these are quantitative measures. Quantitative always means by the numbers, and typically the first one is the utilization, which is always between 0 and 100% of whatever the resource is. And then maybe, a service level indicator could be if there's a certain amount of latency happening, or a certain number of error rates occurring against an API or something. You've got an API, you can see over the course of 5 minutes that literally everything that hit it was a 200. 200's okay, 200's perfect, it's what we want. But then we start getting a whole bunch of 400 responses. Well, 400 responses from our server, mean that the client did something weird. Right? Something happened on the client side that wasn't good. 500 errors mean something's happening internally with our server, right? Our server can't find a resource or something like that. And those error rates can be indicative of either attack, like a lot of 400 errors means somebody's doing something, and again, doesn't matter if it's malicious or accidental. If I accidentally set my, Insomnia is a little tool that I can use for my desktop to hit APIs, right? And if I just set Insomnia to and set up on accident some kind of denial of service against one of my servers that has just went into prod, but I forgot to change maybe an IP address or something, and I'm hitting this server with an undue amount of load, and it's not working anymore. Does it matter that I did that on accident before I went to lunch, or is it more important that we track what's happening? So service level indicators are what's happening in the system, right? What do we want to track? Those feed up into service level objectives. So then we can look at, service level indicators are less than an upper or lower bound. Sometimes from other types of engineering, you'll hear the term upper control limit, UCL, and lower control limit, LCL. Those are very common measures of this from a process management standpoint. So if you ever see a chart that's going like this, and then you've got your upper control limit and your lower control limit, as long as the process stays within those tolerances, it's fine, right? This starts to get into other types of engineering that we're not necessarily doing right now. But I tell you guys all the time, all this stuff like overlaps itself. So if you start looking into process engineering and getting better at what we call continuous improvement or total quality management, you'll see these same types of concepts, even if they're expressed in different terms, right? And then from there, we can generate a service level agreement. What is the time that my server or my system or my whatever I'm maintaining, in this case it's always been Linux systems, what am I going to maintain, and then what's my service level agreement around that going to be? When am I going to get to maybe responding to a customer ticket? What am I going to do with things that are going outside of, we do get too many 500s and the server's not responding properly. I have some kind of service level agreement, even internally, even between internal teams, we have service level agreements of how long it's going to take for me to respond or what we're going to do to get your system back working again, right? So these are some terms. And then it's always important to standardize those indicators. Like if we're doing every 10 seconds, we keep it at every 10 seconds. If we're tracking down to the millisecond, we're tracking down to the millisecond on everything. And then frequency is how often. Data access latency might be one where we say how long did it take to get to the last byte of a read or something like that. Because if we want to track that, then we can tell if something is outside of what our norms are, right? We start to define as we monitor things what the norms of our system are. We start to do what we call baselining the system, right? And then aggregation intervals is, are we aggregating things up and looking over time? I often show you guys, I'm not going to pull it up right now, but often when we're talking, I'll pull up SAR, right? SAR is this tool that gathers all of the information in your system, utilization, and then it stamps it every 10 minutes in your system. And I used to show my junior engineers this because we would have spikes at night on some of our servers. Some of our servers in old company I used to work at, they would get spikes at night of high process load. And the process load would go up to 97%, but only for 5 minutes. Now, if you have a 10-minute increment, right, and you spun up to 97% for 5 minutes, that's only going to show up in your SAR at best, depending on how the window is, at best at 50% utilization. And if you look at that the next morning, none of those numbers are going to look that high. You're going to see 0 most of the time, then you're going to see 50%, and that's going to drop back down. You're going to be like, that's cool. It's not good at defining what we call an acute. Acute is a single point in time, something happens, right? As opposed to chronic issues that happen over time. There's like a steady thing, right? That also comes from medical. Acute, something happened once and at a discrete moment in time. Whereas like chronic is something that's happening that we can track over time, right? But anyways, even then, unless that hits 97% for a whole 10-minute window, we'll never see it inside of SAR as 100% usage, or 97, 100% usage of our system. So it's not a great indicator for those kind of things. We need to use other tools to track that. We need to have what we call a higher resolution of the information, not a 10-minute window that ends up not showing us the whole picture, right? So why are we monitoring? In security engineering, time is of the essence. If we're in the middle of an incident, we need to be getting information very quickly. So if you're ever doing security engineering at the incident level, real-time problem solving, we have to have the data. Give us the data, real time, right? It's the captain up on the deck calling down to Scotty, hey, give me more to the engines, and he's like, I can't, I'm giving her all she got or whatever, right? That's Scotty. But in forensics and after action reviews, speed is less important. We have time to review and kind of go sift through the rubble of what happened. But when we first look at things, this is kind of an important thing to understand about monitors and this is data analytics in general, usefulness of data. Descriptive analytics will give us what has happened in the past, and that can happen whenever. Diagnostic analytics will tell us why it happened in the past, right? And we can we want these to be as accurate and timely as possible so that we can make decisions about what have happened. Predictive analytics helps us to deal with what will happen in the future. We see a bar slowly going up like this, and we know that is eventually going to hit a high water, or it's going to hit full usage, and then we're not going to be able to write to the disk anymore, or we're not going to have any more network bandwidth, or we're not going to whatever. But we can start to predict. And then prescriptive is, if we know what something's going to do, then we can change the behavior up front. How can we make certain things happen, right? And these are the things that we do with analytics, right? That's more for the analytics side of things, but it's important to know this is what we're monitoring, and this is an understanding of our security engineering. All right. So when we say how do we monitor, right? We can push data and we can pull data. That's always true of data. The push method tends to be pushing data into an instance of some type that's ready to catch. This is how our syslog works with logging. One or many nodes push into one or many nodes that are ready to catch the data. Most models just push into one rsyslog server. Your rsyslog server should be able to handle 1,000 nodes, 1,000 nodes worth of traffic into it pretty easily, as far as my normal experience over the years of doing this. But we normally don't prefer the push model. We have to do other things in place to make those instances highly available. So maybe we have multiple nodes behind like a VIP, a virtual IP, those kind of things. Most of us nowadays, the more modern way of doing a lot of this is a poll architecture. So with a tool like Prometheus is scraping all the nodes that it knows about every 10 seconds, and all they're doing is squeezing up the information with like Node Exporter or Ceph Exporter or whatever other of these tools that they have, so that when Prometheus comes by, it can just take all the information. That's what we're kind of doing with more modern ones, right? Advantages of poll: we can tell if instances are down. We can see things up and down. You can manually go target and inspect the health with a web page. So you can actually go hit a web page and get a 200, return back a page, and see the numbers yourself. Now they are very, like Node Exporter are not in a format that you would normally want to read. They're expressed in a format of scientific notation that Prometheus likes, but most of us wouldn't like to read it. There's a lot of zeros at the end of things and stuff like that. And then we can easily add and remove things. So this is kind of like a more modern way of doing monitoring. But we're going to see all that in the lab for sure. So then how do we store the data that we monitor? So data is coming into a system. One of the most common ways that we store things, because everything is flowing, like kind of like that water at the bottom there, everything is just flowing along. Time is, time is the fire in which we burn, right? That's Delmore Schwartz that said that. And the idea that the easiest way, as we're reading metrics in and as we're storing it, why don't we just take this second of time, this discrete moment of time that we read those, and put that in? And that's going to be how a time series database works. They're optimized on one thing: time. They look at the spans of time, they look at ranges of time, but they are optimized to write and read on that timestamp, kind of like the little cherry blossoms falling in that river. That's how I think of it. I just think like time's always flowing along, and then all your servers are just throwing events in there. Or in the series of Prometheus is scraping all of them and writing the exact time that it knows about a metric into its database, which looks a lot like that. So if you didn't know, Prometheus is a time series database, very common, as is InfluxDB. Those are two very common time series databases. But the reads are focused on blocks of time and measurements only, so that's what we're looking for. There's data types typically of single measured records, so we send in like the host, the metric, and then the time with whatever measure value, and then we sometimes have multiple measure values as well. And these are kind of things that we do within our time series databases. So what is alerting? Alerting is how we send information out of a closed system. That's what we were talking about earlier. Alerts are discrete. Did I spell discrete? Actions, don't worry about spelling discrete correctly. I'll get that fixed later. But we're looking at actions in the past. So logs are analyzed and problems or actionable events are found, right, in the past. In current operation, if a threshold is going too high or too low, again, upper control limits, lower control limits, those are the technical terms you might want to read about if you're trying to get into doing that type of engineering. And then we limit some time or those kind of things. And then a service or server stops responding. Those are also current things that might be alerted. Then we have predictive, right? So things that might be happening in the future, and those logs are analyzed and future problems are predicted based on indicators. Hey, thanks, Raiders. We are just recording. I'm recording the Unit 7 of our security engineering lab. I was supposed to do this last week, and I'm just doing it now. I haven't been on streaming too much this week. So we just got done with what is alerting, and then when do we alert? There must be some threshold typically, but also in general, security breaches, unauthorized access to systems or data. And that's also not just people got in, but people attempted to get in as a security incident. Any suspicious activity like unusual login attempts or large data transfers, if we're tracking those things, again, we can have upper and lower control limits, and we can know what that kind of stuff looks like. If we have malware infections, so high CPU or high disk read of things, or the system starts to encrypt itself, these are things that can actually be tracked in systems based on if you're doing your monitoring of CPU, memory, disk, and network, the big four, right? System failures. I want to know if a server's down. I want to know server downtime. I want to know if the network is down but the server stayed up, because that gives me other indicators of things that need to be worked on, right? There's a thing that happens in networking. If any of you guys do networking, there's a thing about what we call network convergence. When something happens to a network, you take a switch down, or you take a route down, right? If you take a route down in the system, all the routing protocols have to talk, if they're link state, they have to talk about what changed. If you take down a switch redundant link, then the spanning tree protocol has to you're probably using rapid spanning tree protocol nowadays, but they have to go align who their designated ports are and what the paths are for things, right? The default, unless you take out that one switch, the what we call the root bridge doesn't change, but if we're not sending stuff there. Anyway, so network outages affect what we might want to alert on. And then critical application errors. Well, what's critical? Because you might say, what's a critical application error? That goes back to those service level indicators. Our system is sending more 500 codes out than it should. Our system is experiencing longer read times from its backend database than it normally does. These are the kind of things that we might want to track or whatever. All right, and then performance issues. Yeah, unusually slow response times. Again, if you don't have an old baseline of how your system normally operates, you don't know what an unusually slow time is, because it feels slow. Feeling slow is irrelevant. As an engineer, I used to get on calls and people would be like, "System just feels kind of sluggish," and I'd be like, "Guys, we need something. we need to." So it's not that's not a bad description. If somebody came in and was like, "Wow, my arm hurts, so we got to do something." But if a doctor just looked at you and said, "Yeah, it looks like your arm does hurt," the hell's that? That's not right. As engineers, something can feel sluggish, but then we have to go quantify it. We got to go deal with the numbers, right? So high resource time, CPU memory, unexpected changes in system behavior. These are things that we want to look for, right? And then anomalies, any deviation from the norm, right? I'll show you something in my home lab real quick. Hold on. So this is the home lab. And let's just go to ProLUG. Here's our lab servers, right? And let me pull this out a little bit so you guys can see. Here's a CPU spike every night. This is every 7 days, right? So every 7 days in the home lab here. I have a spike every night. 512, 513, 514, 515, 16, 17, 18. There's a spike technically going on right now in my home lab. But look at that pattern. What if I told you that doesn't bug me one bit? Because I'm very used to seeing it. That goes back as long as my monitoring goes. Because that's when all my Linux boxes run their ClamWin antivirus just to scan to make sure nothing's weird on them. That's what that is right there. In fact, I used to have a check that checked that for all of their alerting coming in. And then how about this? Same thing with memory. We have high memory usage on those boxes coinciding with that. That is not like a security incident or security alert. That's a pattern that we're used to, right? That's a security baseline, or that's a system baseline that we know that the system goes high. What if I told you from like 7 a.m. until 5 p.m. every day, all the servers at YouTube spin up because all you guys are watching your cat videos when you're at work, right? It's the same type of thing. All right, so when do we alert there? So here's our little review before we get into like the lab stuff and the worksheet. What do we monitor? Telemetry, which are metrics at a distance. That's what all of that information was. We look at trace information, which is how the data are flowing through our system. And then logging. Logging we hit heavily last week, so we're not going to set up logging this week, but we did it in like 3 or 4 labs last week. So you guys can go look at that if you want. That was Unit 6. How do we monitor? Well, we monitor things either with a push or a pull method, and then if we use a push or a pull method, we're typically sending data into a time series database, which is going to allow us to look at the data in spans of time, and it's optimized on time. That's always very important. What is alerting? Alerting is when we decide that something has crossed a threshold that we need to tell somebody outside of the system. We're outside of the system, we send something out. There's triggers, there's windows, all those kind of things. That's priority, right? And then how do we alert? We're going to set some of that up. Okay, So questions, message me if you have questions down in the Discord. But let's get to our actual, where's this at here? Here we go. All right, we're gonna pull up here's our worksheet for this week. By the way, the worksheets are in the Discord, and also I think I have, hold on. I think I have the PSC. I think this is our security. Hold on. Let me go pull this up. Yeah, so the guys already have Unit 7 up. I'll pull this up if anybody wants to see it real quick. And I'll link this for Unit 7. Let's go see. I haven't even looked at what they have Unit 7 at. Here they go. Yeah, they do have the worksheets up and stuff. So I'm going to link this to anybody that wants it. Here is, again, all this stuff is free online. There's our book. And here's the things that I'm about to show you right now, but I'm just looking at them through my original Word doc. So here's the stuff. Okay. So here's my original Word doc, which is ProLUG Security Engineering Worksheet. You fill it out and you give it to me at the end of the course. This is a 10-week course, and we're in Unit 7, so most of you probably don't want to try to start it yet, but it is free course, and it's down in our Discord. Anybody's welcome to do it. You probably just won't finish it right now and get the certificate. Here's our discussion question 1. Read about telemetry, logs, and traces. There are many good sources, even from Microsoft. And I say go in here and read about how does the usage guidance of the blog at the bottom align with your understanding of these 3 items? So telemetry, logs, and traces. You go in and you say, okay, these engineers, whoever they are, put together, let's see if we can get this. They've got what they think metrics, traces, and logs mean. And then they give down here at the bottom a little bit of usage guidance, right? It's a quick little read. And what you do is you come in here and you look and you say, what other useful information might you find? I even let you guys, if you're doing discussion questions, I let you guys use AI, whatever. Just let us know how you're finding it. I don't let my college students do that, right? But and then what's useful in this in securing your system? So these are reflective questions for you to think through and then talk with other members of the community kind of about your understanding of these things, right? Same type of thing you do in college. We're just doing it down in our ProLUG group, right? Then discussion post 2 is, when we think about our systems, sometimes in an air-gapped system, it's simple to think about because everything's closed in, but alerting or reporting is the opposite. We have to think about what we want to send out. So now we look over at this Google Doc on alerting, and we say, what is the litmus test for paging somebody out? Now, paging is a term that we've used forever. Probably even before there were actual pagers, people would page over like an intercom system. But okay, let's just say it's been around a long time, and it's the idea that we send you an alert to your phone, right? We used to carry these little things called pagers. But then it's what is over monitoring versus under monitoring. Like what if I took this page that I showed a little while ago? What if I pulled this up and I just had like 10 times the stuff going on the page and nobody could read it, nobody knew what it meant? That would be over monitoring. However, in my case, I look at the CPU, the memory, the network, and the disk storage of my devices. Same exact things that I've been talking about are the things that I want to know about my system. Up here I see uptime, so I see when my system's last rebooted. And then I see over here how many users are logged into my system because I allow users to come in from all over. And then we have all kinds of other logging that you guys sometimes see when we do like normal streaming, not just the discussion like we're doing now. So we come down here. Here's a bunch of definitions and terminology. We talked about telemetry. We talked about tracing. And then what is a span and a label in regards to those things? So in the worksheet, these are things that you can go maybe read more about. They're all things that I mentioned. And then you can go dig in and read about those things if that's interesting to you. Now, here's some links, some useful tools. They say here, or I say here, to go do monitoring and alerting, which is our lab that we're going to do here in a second. And then I give you some digging deeper. Go into Wooza, which is a nice SIEM, security information and event management system that will do some of this for you. That's open source. You can play with it. And then maybe you even want to compare that to like Splunk or something like that, which is one of these paid for tools that do these things. And then some reflection questions for you, right? All right, so let me get this one out of the way, and let's go pull up the other one. And here's our lab for monitoring. So if you wanted to do these labs with us, or with me right now, this is what you would start to do. We would come right here, move this over here, move this right here. And here is the lab that you guys would work on this week. And this is typically what people turn in to me when they're all done. They turn in all 10 of the labs for all the different weeks. Actually, it's only 9 weeks of work, and then the 10th week is a final project. But here's the Unit 7 lab monitoring and alerting. You need some kind of lab server. You can build your own, or you can go follow in our syllabus that shows you what to do. And then down here in the labs, these labs focus on pulling metric information and then visualizing that data quickly on the dashboard for real-time analysis. So here's what we're doing in the first one. We're going to turn on a tool called Fail to Ban. Fail to Ban is this cool little tool that will lock people out if they're doing stuff they should. Like if people come to your servers and they rattle, like almost like they went to the front of your house and rattled the door 5 times, it'll lock it down forever. It's like one of those cages that falls down like in the movie, or if you ever watch Rick and Morty, you know, he just has the things that slide down over all the doors, like the ballistic shield doors over all the windows and stuff. It's the same kind of concept, right? They're trying to keep all the what are they? The parasites from getting out, all the little space parasites. So we come here and we're going to make fail to ban on control plane. We're going to log into node 01. We're going to come back and get ourselves jailed. And then we're going to go look at the activities, look at the ban status, and we're going to unban that IP and do fun little stuff with that. So here's the lab. And then I say how you can go and add more to it, right? And then this last one, do I have this one send out? Yeah, so we can have the last one send out. Okay. So let's come up here. Let's do this lab real quick. The lab control is right here, or the link right here to the lab. And I will link it to anybody that wants to follow along with me. Hey, Kolkus, how's it going? We're just recording Unit 7 here. So I'm going to make that a little bigger for you guys. You guys don't have to make it as big on the screen as I do, because it doesn't have to be, like for you guys, you just need whatever you can see. I like to make these a little bigger so you guys can read them, but then it also makes it slightly, unfortunately, a little less readable for you guys as we go. Thanks for the follows, guys. I've missed a few, but I appreciate it. Hopefully this stuff's useful to you guys. And I haven't mentioned it much, but we do have a Discord, and the Discord is free, and you guys are welcome to go hang out in there if you want. I think the Discord is one of the better aspects of our group, because what happens is you can go in there and persistently work with other people that are doing the same type of stuff. All right, so anyways, your team's testing failed to ban. They want to protect the SSHD, that's the SSH daemon on your system. It's a server that's running that allows connections in, right? Like I could just SSH at any time to node 01, but nothing's protecting that in our system. There's obviously the authentication method, but if somebody were to just bang on that door over and over again as the root user with bad passwords, it's going into logs, but nobody's ever changing anything. There's intrusion detection in place, but not intrusion prevention, right? Intrusion detection is, I'm watching it, but I'm like, I always tell you guys, it's like one of those Nat Geo type, they're like watching like a little baby, something get eaten by a snake or something, and they're just like, oh, this is terrible, but I'm not going to help. They're behind their camera. They're like, this is awful, but the world wants to see it. And you're like, and everybody's like watching it going, just save the little poor guy. But they can't intervene, right? Well, it's the same idea with an intrusion detection system. Intrusion detection system will watch all the bad traffic go by, and it'll alert you, but it won't do anything. Intrusion prevention, which is what we're setting up, will make changes. Okay, so come down here. Let's install fail to ban. We're just going to install the default package. And then I always tell you it's a good idea to watch. Ooh, that looks like some weird content coming out, but let's make sure that there's no errors, okay? And then we'll run fail to ban client version, and we see fail to ban version 1.0.2. And that looks good enough for a start. And we can do, if we wanted to, system CTL status of fail to ban, right? And we see that it's active running, but it doesn't know what it's doing yet. It's just keeping an eye on things. So let's go run a configuration for the fail to ban jail. So I'm going to drop right here, and I'm going to use this version of the jail right here, and I'm just going to drop in these values, right? And maybe I come here and I back these up. And now it says right here that we need to make sure no other SSHD exists. So I'm going to do a /SSHD, and then I see this one, and I'm just going to delete that line, delete. I don't need those other ones conflicting. You'll have problems if you don't take those other ones out, right? So then I come down here and I say review the configurations for Apache. You can review all these other things. So Apache, and you can go see what is Apache going to watch and what is it going to look at for errors, and then we could start to just look up all types of different things. There are all kinds of things that are default. Nginx, there's Nginx configs, and you can also learn their language, and you can change the way that Nginx behaves and what port you're watching, HTTP and HTTPS. Those ports are defined here as their service name, which maps back in Etsy services to 80 and 443, right? That's how we know those. Anyways, just showing you that there's all these other things you can go spend time with if you want to. But the next thing I should be able to do is restart failed to ban and verify that it's running. So it is running. We didn't have that error where we didn't turn off the other SSHD jail. So, okay, we've got that working. Now we're going to go do this next part, which we're going to SSH to node 01, and we're going to come back as an invalid user and break stuff just for fun. So we're going to jump over there, and we're going to try to come back in as invalid user multiple times. So I'm just going to hit enter, and right there I stopped being able to connect in. I have locked SSH. I have locked node 01. I have banned his IP. That's what actually happens. His IP can no longer connect to this server. So I'm going to come over here, hit Control C and exit. Right, it says right here Control C and then exit. And we're going to go back to control plane, and we're going to look tail-20 at var log fail to ban, and we're going to see that fail to ban filtered out this IP address eventually, and it also banned it. So here's the jail starting, and here's the fail to ban actions, and it banned right here. Get a little wider for you guys. Banned 10.244.20.18. It's the only one that was hitting it, but that's also correct. So I can go look and see just which ones are banned if I wanted to see who's gotten banned, and there would be a big list of these. By the way, I can look at this in my home lab, but this is messy in my home lab because, check this out. Pull up the home lab real quick. In my home lab, where are we at here? Oh, I forgot that I was still running that. Don't worry about all that. In my home lab here, I can just run my fail to ban, and here's all the banned ones. Let's see what that number looks like. We'll throw a head on it, and it should be. Oh, see if we can throw more on it. It's literally like 50,000, right? We've got a monitor for it, but I thought I had a way to see the top of that, but that's fine. We will we'll mess with that later. I thought that gave at the top like the exact number, but I guess it doesn't. But suffice it to say over here we're doing a test, so we only have the one. All right. So we come down here. What's the IP? Is it the one you expect? Yeah, it's the one that one connects to this one on. So we can unban that IP real quick with this command. So fail to ban client set SSHD, that's the jail we're using, unban IP, and the IP is 10.244.20.80, is that right? 18, right? So we'll unban that, and then now we can go SSH back to node 01, and we should be able to SSH back to node or control plane and have no problem. Boom. So I'm going to exit and come back to control plane so I don't have any problems in the lab later. And did it connect back correctly? Yeah, everything worked. So we come over to the second part, and we're going to install Grafana and Loki on the system. So we're going to install some things that allow us to see these logs on the dashboard as these things happen. So we're going to start the Grafana install. This is not really that important to the lab, the Grafana part. There's other labs that go into the build of Grafana and that kind of stuff. We're not really worried about that for these purposes. We're just using it as a viewing tool. So we're going to come down. We're going to get this all going. I explained this in other videos and stuff, so we're not going to spend too much time with it. But suffice it to say, we need to turn Grafana on for now, right? All right, so we get that going. As soon as that's done, we're going to do a daemon reload, and we're going to make sure that the process is started for Grafana. Grafana takes about 10 seconds to come up from the time that it says it's started until the time it's listening on port 3000, right? So we're going to let that go. Do a daemon reload. We'll start Grafana. We'll see that it's running. Cool, cool. Give it about 10 seconds because, again, if we watch it, see how it's not listening yet? Takes a few seconds. It's putting some stuff in order. It's turning on the web page, doing all the stuff it needs to. And now we see that Grafana is listening. If you've set that all up properly by clicking those buttons, you should be able to go right here. This will be linked to your exact Killer Coda instance. And then you will have here the web page for Grafana. So I'm going to modify the username and password, which by default is admin. We're going to change that to what we need. So admin, modify this. Don't want to save any of that stuff. 1, 2, 3. Save our new password and everything, and now we're in Grafana. Don't save it. Okay. Come down here, we're going to install Loki, so we're going to cd into opt Loki. Opt is a place where we normally put agents on Linux boxes or third-party type software. We're going to cd in there, and then we're going to download everything we need and unzip it and make sure that Loki is executable. We're going to copy in a configuration that I've made from before, and we're going to do a daemon reload. Now, if we go look at the configuration for Loki, everything on here is default. But if you're setting this up in a home, you're going to change your IP address that you're sending to because it's probably not on the local server. And you can change some other things in here. I would always set your reporting enabled to false for your analytics because that's not false by default. And we're going to put that system file. Here's our system file for how we start and run Loki inside of systemd. We're going to enable it. And then we're going to check to make sure that Loki's running on port 3100. Okay, cool. That architecture is for different labs, and that's what we, have done in other labs. Even last week, we were doing that as a lab. So I'm not focused on that right now. We're focused on this testing of the failures going in there, right? So you can research that Promtail can push over logs. So we're going to make a directory for Promtail, cd in there, download the tool, and extract it. And then we're going to copy in the right files. And right here at the bottom, I want you to see that instead of our normal 2 syslog and authlog that we normally pull out of Ubuntu systems, these are ones that I had configured before. But then there's also a fail to ban. And now fail to ban is also going to be sent out of the system into Loki, just so you guys can see that. We're going to daemon reload it. And, we need to probably copy it in there and then do a daemon reload. There we go. Yep, and then now we can see that Promtail's running on our system. So that's just a matter of hitting all the buttons on the left, right? Everything will work, and everything's connected. All right, so I hit check, and I go forward. You set up all the pieces. Now we're going to create a dashboard in Grafana and verify that everything's flowing through there. All right, so we got Grafana up. We're going to set up the Loki data source. So right here, boom, connections, Loki. Once we've got Loki as a new data source, you're going to set it to 127.0.0.1 on 3100, and you're going to hit test, and it's going to tell you that you successfully connected. By the way, all the things I did are right here. They show how to connect. And then you're going to import 13639 to view logs. So you're going to come up here and say, I want a new dashboard. I want to import the dashboard here. And I'm going to use the Loki data source that I just set up on the system. And I'm going to import it. So here is auth, fail to ban, and syslog coming into our Grafana instance. So here's fail to ban, and here's all of those entries that just happened. I'm going to go ahead and make sure that this refreshes every 10 seconds just for fun. And then we're going to go into the next part of the lab here. Change the app field to fail to ban and retest your failure condition from no to 1 earlier. So my failure condition, I can press up a whole bunch of times, or I can type in history. And how did I fail earlier? SSH to node 01, history. Whoops. If I spell it right. And I could just bang number 4. And I can go, there's my failures. There's me getting locked out. And right here, I should see those failures happening. And I should see the ban occurring. That's 1350. Yes, that's right now. That happened in the system right now. Earlier we had the ban and the unban, and now we just jailed ourselves again with a ban. So ban found. Let's go unban it again. Right, we're just testing our functionality now. Let's unban that same IP address, right? And maybe it's even useful to see right here. Oh, well, the unban's over here, isn't it? Before I do the unban, where's it at? Oh, I see that. Here it is. Here's our set unban. I'm going to leave this. I'm going to pull this over here. You can have them in multiple windows if you want, right? Leave this over here. Come back over here. And I'm going to set the unban right now, and then you're going to see it happen on the right. Over here on the right, you should see that come through. So set the unban, and then we can... Yep, there it is. There's the action. Right? Unban the IP address. So we have now tested that we can, well, if you've never used fail to ban, you've now tested fail to ban too, but we've tested that functionality all the way down to where it logs in the system. But it is not alerted yet. There's no alert yet. So if I wanted to, I could unban. Okay, so it's already unbanned right now. We've got it unbanned. So now what we can do is we can come over here. We've set it back to unban. And then we can continue on with the lab, which tells us to do a little bit more. So in the lab, were you able to see the IP address and notice it was unbanned? Were you able to see the notice offense in Grafana? And what other questions do you have this lab? Okay. Oh, this other one. This is the telemetry one. This is the one that we're going to send it over. Okay. Okay, yeah, we'll send it over with the next one. All right, so that's that whole lab. You got everything. You did this right here. And I thought I put that picture. Apparently I didn't put that picture in here. All right, well, it doesn't matter. Let's go on to the next part of the lab. So I'm going to close that down. We'll let the Grafana go away. And then we're going to come down here, and the next part we're going to do is called fail to ban with log monitoring. So we did that one. Now we're going to do fail to ban with telemetry data. So we're going to have control plane, and we're going to have node 01, and we're going to set up fail to ban again. And we're going to get ready to ban that IP address. And when we do, we're going to set up, in this case, we're going to set up Telegraph Influx DB and Grafana. And Grafana is going to alert on a threshold of that, anybody getting banned, and it's going to send it into our Discord. So that's going to be something that we're going to set up right here. All right? So let's do the lab. Here's the lab if anybody wants to do it with me. Labs are free on Killer Coda. So is all that other material free. I linked earlier to the book if you guys need it. Again, the guys have been putting the book together as we go, and it's turned out really good. Hopefully people find that book of labs and book of kind of all the activities we've been doing useful. So your team is testing fail to ban to protect the SSHD process on your server. Same thing we just did. So you've decided to build a proof of concept, right? This is just a working test to make sure that everything does. A proof of concept, or what we sometimes call a minimal viable product, is a system that is designed to meet all of the technical requirements, right? It's designed to be what we call fit for warranty. It is never designed to be fit for use. Fit for use is like how a thing operates when it's under load. Proof of concepts and or minimum viable products are just there to check all the boxes that it can do the activity at least once, right? It can prove that it works, right? That's what proof of concepts are. All right. Very important in engineering term, because if you want to apply something in a company, sometimes you got a little sandbox where you can build it and prove. Like, it's almost like you start a little fire and then show it to management, and then you go light all the torches with it because it works, you know. However you want to think of it as an engineer. All right, fail to ban version. I'm not going to go super deep into this because we literally just did it, but we're going to come down here. We're going to fix the SSH on the server to have these extra values. Let's just take those extra spaces out, but it's fine. Oh no, didn't mean to do that. And then I don't even think the spaces actually matter, but I'm still going to just clean them up. And then we hit /SSHD and we delete these lines that don't matter, or we can comment them out. It literally doesn't matter. We just have to have them not be read. And then we're going to restart fail to ban and verify that it's working, which it is. That's good. SSH to node 01 will break the system, or well, we'll test that the system properly locks out an IP address or bans an IP if it's doing stuff it shouldn't do, and we see that it did. We can go check and see that, yep, somebody just got banned right here. There's a ban. And then we can see that we can see who got banned. It's 10.244.22.246 this time. And then we can set that fail to ban client set SSHD unban IP, and we can unban that IP. And then we should see that nobody's banned, and we can also see that an unban action occurred. So we've got logging for all the things happening, guys. This is a little different because now we're going to send the actual, we're not even going to send the logs necessarily. We're going to send the telemetry of the alerts, right, or of the events. So we did all that. We're going to go to the next part, and it says that we want to test Telegraph, Influx, and Grafana. We're going to set those up. Again, since we just saw it and we do it in other labs, we're not going to spend a whole lot of time on it. And we're going to get this going. Okay, get the key ring, make sure that it's set, and then install Grafana. Oh, no, that's just apt update first. Okay. When that's done, we're going to do a daemon reload. We're going to start our Grafana server. Sometimes it kind of hangs a little bit. It just takes a little bit of time. But hey, free labs. It's awesome that they provide free labs for us to do this with. We'll do a daemon reload. We'll check it, make sure it's started, and then we'll go check, and we'll see it running, but we will not see it listening for the first 10 seconds or so. So give it a little bit of time. Once you see it running, it says right there, wait 10 seconds. Now it's listening, and we should be able to click here and go into our Grafana instance, set the admin IP, right? So admin to something a little more, so annoying. There we go, some kind of password, and now we're in our Grafana instance. Good. Come down here, we're going to install InfluxDB2. So we're going to put that on, we're going to install it. Then we'll start it and make sure it's enabled to listen on port 8086 by default on our local system. So we're going to walk through this next part. Again, I have other labs that deal with the you know, what's going on in here and what it looks like to set up InfluxDB. But at least for now, we'll get it going. And there's a couple of things we need to do in our lab once we've got it up, right? So we see that it's running. We see that it's listening on 8086. That's awesome. We can now connect to that for the first time in our lab. And the first time we're going to set up some values. Now, what I would advise in any lab environment like this, I always show this to my college students, right-click and say Open Image in New Tab. And there's the image of what I want. User Lab Test. So, user password is whatever your password is that you want. Lab test. There's one thing I have to save right here, guys. There's one thing. I said okay. Never. You normally would never show this on the screen, right? You would never show this to like a group of people or out on Twitch or something, but this thing's going to be gone in an hour anyway, so I don't mind showing a key like that. But I need to capture that key real quick. So I'm going to go right here, that API token, as it were. I'm going to throw it right there, just for now. So I know everything else that I need. I've got that picture here, and I've got all my other stuff. So I'm going to keep going through the lab. And it says that once you have that, we're going to install Telegraph. So let's get Telegraph on our system. We're going to apt install and get Telegraph going. I think we have it. And then we're going to set the values inside of the config for Telegraph right here. So vi etc telegraph telegraph.conf. Wait till that comes up, and I'll show you guys what we're setting. These are you know, very straightforward things, but you just have to learn and work through them. Now we do them in other labs, so I'm kind of blowing through them a little faster than normal. But influx DB, because they're not the point of the thing. They're not the point of what we're talking about. We need to uncomment this. Uncomment this. That's correct because it's on the local box. But if it wasn't correct, we would go to whatever server was functioning as our InfluxDB. We need our token. We need our organization, and we need our bucket. Now our organization was test, right? Where's it at? So right here. Organization was lab, and the bucket was test. See, I was testing you guys. So this is lab. This is test. And then we need our token, which may still be in my paste buffer. Let's see. There it is. Yep. So it's still in our paste buffer. But also I saved it over here just in case I needed it, right? And if I have those 5 things, that part of it's good. But there's one other thing I need to go set up. So I'm just going to go ahead and escape. I'm going to hit / and I'm going to set up fail to ban. So / will search ahead in a file. And I'm going to go here to inputs fail to ban. And I'm going to say use sudo true. It says it right there. We're going to set use sudo to true. It's right there in the lab. Boom. These are the values that you change right there. Escape : WQ. And we are going to now, we're going to set up a file. This is where we just set up sudoers to allow, if I say like this right now, sudo-i or sudo-l-U telegraph, which is a user on my system, they have no permissions yet. We're going to give them permissions in sudoers to be able to do these things right here. Unless you think, oh, Scott, it's hard to figure out how to do this. One, if you do a lot of sudo, this isn't going to be super hard. And two, most of these tools that exist and most of like the documentation will have the minimum required things. So look, we've got a command alias that fail to ban, that's our command alias, is allowed to do these commands. It can check the client status and it can check any client status. So for any jail that we have, that's what that defines. And then down here, it says if you're the user telegraph, you can do all of those above passwords for fail to ban, right? There's a command alias mapped to the commands with no password. So the telegraph user, the telegraph process can access those commands in our system without having to do any password. So escape : WQ, just to re-emphasize that, this is what our system thinks, sudo-l-U telegraph, that the telegraph user can do on our system. Very important because the process, check this out, ps-ef grep-i fail to ban, telegraph. Telegraph is being run. Oh, we don't have telegraph running. We got to restart telegraph. Hold on. When we look at telegraph right here, telegraph has been started by system D with the username telegraph. So the process and the user telegraph has to be able to access fail to ban commands or they're not going to be able to work. That's why we have to set up that sudo. Now, if you wanted to change this back, if you said, you know what, that's stupid, I don't agree that telegraph should be running as non-root. Look, guys, the reason we separate things out is a very important security concept of, well, separation of processes, right? But it's a non-root process to run an application. You can change that though. You guys are root on a box. You can literally do whatever you guys want, right? You would change that here. You would vi our etc systemd system, and then we would find telegraph in here. Whoops. If telegraph is here. If it's not here, this is how we would find it. We would go systemctl cat telegraph, and we'll see how our system called it. This is the file that's being used, and I would vi that file. Whoops. Oh, it's probably easier to just do it that way. But okay, we'd vi the file, and we would change the user right here. We would just delete this line, and then system would start it as root. I don't advise changing that. I'm just telling you that you really do want your processes to run like this, because now if somebody compromises telegraph, they can literally only check fail to ban. They're not the root user. This is a very important thing with like Prometheus instances and stuff. It's a very important thing when we do containerization with Kubernetes. You always hear about no root or no privilege escalation, and what we call no sudo or no being able to improve our move up what we call escalation of privileges, right? So there's none of that. Anyways, all right, so now we're going to go set everything up. We've put all the pieces together. Let's go get it to all flow all the way through. So we're on our Grafana instance over here. And it says that we can set up InfluxDB2, and we can set up all of the information right here. So we're going to go test that, and we're going to make a dashboard that's going to do our basic things. So we'll come here, we'll say connections. We're going to set InfluxDB. Here's our InfluxDB data source. I can move this over so that we can see the things at the same time. But right here, as our InfluxDB data source, we're going to set it to 127.0.0.1. So we want to use the FluxQL language right here, query language flux. IP address 127.0.0.1.80.86. You guys see I'm doing all the things that I'm telling you right here. And then we come down and we have to set up our organization, which our organization's right here. Right? Organization is lab. Default bucket is test. And our token, gotta go grab our token from wherever we saved it, right here. And if that all works, when you hit save and test, you're going to see that your data sources are working. This is one of my favorite things about Grafana. I don't have to wait until later to find out stuff's broken. It tested right there for me. My Grafana is now touching InfluxDB, and it's seeing the right number of 3 buckets. 2 buckets are default. 1 bucket is the one that's coming in from Telegraph. So I actually know Telegraph's working now too. So I've got all my pieces working, guys, right here. All right, so we save and test that. That's good. I can then come back over here. And I'm going to make a new dashboard now. So I'm just going to go to dashboards, and I'm going to say new, just make a new dashboard, and I'm going to add a visualization, and I'm going to use InfluxDB as my default source. I'm just going to copy this in as my query right here, just for fun. Drop it right there as the query, and if I save this dashboard, and just hit save, it doesn't matter. Now here's my panel, and I see currently there is nobody banned because we're at 0 banned. And if I want to, for fun, I can escape :Q, get out of there. I can go and do my little song and dance from earlier. So just sh to node 01. Let's make sure this is, let's go back to dashboard. Let's make sure that this is refreshing every 5 seconds. We see that it's currently at, you know what, that's too large of a window, so I can set this down and say, you know what, only show me between, my soft max will be like 5. Whoops, 5. So let's say whatever. Go back to dashboard. So now it's 1 to 5. This will be a lot more pronounced when I do this. All right, we've locked ourselves out. Exit to go back over here. And then now I sit here for just a few seconds. I'm going to take my hands off the keyboard. It jumped up to 1. You can see that right there. Jumped up to 1. Now it's going to stay at 1 until we wait a little bit here. By the way, this is the last 6 hours. I'm going to change it to like the last 15 minutes. And now while we sit here and talk for a little bit, that's going to move out because now we've got 1 band IP. We're tracking 1 band IP right now. Okay, wait that. We're going to give that a few seconds. And then I'm going to come over here and I'm going to unban that IP. Remember that unban command from earlier? No. Right? So our unban is bang 14, right? And it will unban that. And now over here, we're going to see that drop to 0 in 5 seconds or so. That's going to drop down to 0 because there's no longer a banned IP to our system. See it? So if we have that, we can send an alert on that. So let's go send that alert, which is, by the way, the next part here. So save the dashboard, call it failed ban model. You can call it whatever you want. I don't care what you call your lab. It's your lab. You guys can do whatever you want with it. So what I'm going to do then is I'm going to come over here. I have to go grab, I have this other piece of information that I need. I'll go grab it over here off screen. Okay, so whoops. I forgot that I had encrypted it, and I don't remember what the I don't remember what the damn password is. All right, hold on a second. I gotta pull up. Now I gotta pull up yet another password to get this other password. Hold on a second, guys. Sorry, I forgot that I had to go pull password after password up because of this layered security. We're doing a security course, so I had to be secure, right? And this is quite secure because it's locked down multiple times. It's kind of funny. All right, encryption key, encryption key. All right, I've got my webhook now. So I need this webhook for the lab, but unfortunately, you have to be part of the course for us to show it to you. You could do your own. You could build your own Discord and do your own webhook. It's super easy to do, right? I mean, go look. There's a billion blogs online about how to set up your thing. But can we make a 1 and a 0 happen? Yes, we can make a 1 and a 0 happen over here. Let's go make an alert for it now. So we're going to go into Discord webhook. We got our Discord webhook, so we can go. We got a running Discord server. Check, check, check. All that stuff's good. Let's move this out of the way. Move this out of the way. Okay. So we're going to set up dashboard alerting. So we're going to come over here, and we're going to go to, or Grafana alerting, rather. We're going to go to alerting. We'll say the dashboard, whatever. Update all that. Update that. Yep, I want those all saved, whatever. All right, so we're going to go to alerting. And the first thing it says right here to do is to set up, create a contact point for Discord. So we're going to go manage contact points. And we're going to create a contact point. And we're going to make it one called Discord. And the integration is going to be Discord. Well, that makes sense. It says right here, set the name, Discord, webhook, and then Discord integration. And then we're going to go ahead and drop in our Discord webhook, right? You can only see part of it there. But now, as soon as we have that, I'm going to go pull up our Discord right here. Here's our Discord. Cool little Discord tool. And I'm going to go down into our sandbox here real quick. So sandbox is where all of this stuff gets dropped. So here's our sandbox. And you see ones that other users, damn it, you see one that other users have been making as they've been doing this. Oh. Gotta try to keep myself calm here. All right. So there's other ones that we send things in with webhooks and stuff. And I'm going to hit test right here. Send test notification. And there it was immediately. There was a test notification that came in. It said test alert from Grafana folder. Cool. All right. Good. Now, we could add optional settings and notification settings and stuff. But we're going to go ahead and save that contact point because we know that's working. We're going to come back over to our lab here. And we're going to set up an alert rule. So I'm going to come back here to alerting. I'm going to set up an alert rule. And now our alert rule is a new alert rule right here. And we're going to go ahead and call this, let's just call this Discord test. Boom. And the query alert that we're going to use is the same one from before. So I left it right there for you. We're going to drop that query alert in right there. And this should not be firing right now. You say, well, how do you know it's not firing? Well, we left it at 0, right? So it's in a non-firing state. So let's say if that is above 0. So if it goes above 0, 0 is fine. If it goes above 0, it's going to crit. Or it's going to go off. So here's what had happened with it, but here's its current state of 0, right? Do you guys all see that? And you can come down here and you can say, what's our alert condition? Well, our alert condition right now is normal. We're good. Not going to send. All right. Come down here. We can add, we got to make a folder, right? So we'll just call this alerts. It says over here, make it alerts, whatever. Then you got to come down here and you got to set an evaluation behavior. And we're just going to call that like alert. And it'll just evaluate it every 1 minute. But look, you can have it trigger only every once an hour if you want. But we'll go ahead and say every 1 minute. Go ahead and create. Okay, good. And then keep firing for none. It's only going to fire once, or maybe 5 minutes it's going to go off and keep alerting to a dashboard or something. Or is it going to keep alerting to, escalations, right? And there's all kinds of stuff we can do here, but that's fine. And then the contact point we want is the Discord. Here's our Discord. You could set email though, by the way, if you're running email in your company. And then the notification summary is het stream recording. And then the description is we have a jailed user, right? And then maybe if you've ever, this is actually kind of fun because I track stuff like this professionally. You know, I'll see something happen and then I'll see the user call in. I'll be like, yeah, you just got banned, didn't you? Oh, yeah, I'm watching. And they'll be like, oh, man, this guy's on it. But really all you're doing is you just got your monitors up and you just get the alert first. You know, that kind of stuff. And then people are like, oh, this person's digging in the system and just watching the matrix scroll by. And you're not doing any of that. You're just using your freaking tools. All right. Anyways, you can do that stuff when you're young. But as you get older, you're like, I'm going to let the tool do it all for me. All right. So this is all good. And it's normal. It's not triggering right now. So let's go make it trigger, right? What's the fun of this if we can't make it trigger, right? So we're going to watch the state go from normal. Let's go over here. We know we got a few seconds after we do this. So watch, we're going to go, well, let's get our Discord ready. Where's Discord at? Okay, we're going to pop up Discord in a second so we can see it. And we're going to go, all right, we're failed out. Pull up Discord. We're waiting for that. We're also going to see over here that it's going to go out of the normal range. And remember, it's only testing once every minute. So we're going to see it go out of the normal range, and it's going to say, like, basically ready to fire. It's going to say triggering, and then it's going to say firing. So we can just sit here and watch this. It's still in normal. Still in normal. Nothing's happened yet. This page refreshes slower, and you can't set the refresh on this because we're just watching the alerting rules. I'm just telling you, you will see it here start to go into like a triggering state. So it's still normal. It hasn't tested it yet because we set it to test every 1 minute. It still thinks everything's good. The dashboard is updated. The dashboard is up though, right? So the dashboard is up. Right, this is about to start triggering, and then we'll see it fire over here. So we could, if we were watching the dashboard separate, we could also see that. Let's let this run. Now it's pending. See, it's pending because it thinks it's firing, right? So it's in a pending state. And then when it fires, we're going to see it come right here in the sandbox channel, and it's going to say het stream test or whatever. It's going to give the whole value all the way through. So while we're waiting for that to fire, because it's about to fire, just to let you know, we have, Discord. You guys can hang out in there, talk shop. We got almost 4,000 engineers in there. You can see over here, like the discussion course stuff. So if you're part of our courses and doing them, you have to do discussions with people. You have to, and this is true. I mean, this is kind of funny. It's like, it's true in the industry too. Like, you have to work with people. You can't have people that you won't work with. You can't have personality types you won't work with. Yeah, you can dislike it, but you still got to do it, right? Like, people get hired, you got to work with whoever. We have a complaints channel for that, right? All the people that you don't want to deal with, but you still got to deal with them. And it's the same kind of way here. Like, you got to put your ideas out there and let other people kind of challenge them if you want. That's part of academia. If you guys don't know, that's a big thing that happens in academia in general, is the proper usage of argumentation to further a set of beliefs or things. Now this is firing. Now it's alerting, so we should see over here that thing triggering. It should go off over here. I'm not seeing it yet though, unless I put it in there. And our description will say that we have a jailed user. Let's go ahead and let that refresh here. You don't have to do any refresh. It'll fire over there. Ah, there it is. There it is. Description, we have a jailed user. Summary, het stream recording. So those are all the things that we set over here inside of this Killer Coda lab. And then now you see it right here, right? You obviously can't use the silence because that's not going to, that goes to localhost. We'd have to configure some other things for that to work. But the point is we were able to get a Discord alert to shoot all the way through our system. All right. So close this stuff up. And we come over here, and then we answer some questions about it, right? So this is what we did. We set up fail to ban. We SSH'd over and triggered. This is our trigger events up here. And then down here we had, I still have to do the node exporter part. That's for another day with the lab. But we set up Telegraph, InfluxDB, and Grafana to watch the metrics on a dashboard. We could see it go 1010. And then we configured Grafana to send us an alert when somebody got banned forever, right? And we could set that up, like in my home lab, we could set that up to send out if we wanted. Anytime somebody gets themselves banned out forever, it could just go in there and go, haha, whoever got banned. I don't do that because so many users, well, not even users, so many bots get banned every day that it would just be noise. But anyways, do you see fail to ban in the dashboard? Yes. Did you test the alert to trigger to the Discord channel? Yes. What other application, where else would you use this? Like, by the way, we use Discord. You could use Slack. You could use Teams. I've sent these alerts to all of these things, right? And then deeper challenges, go dig in on some of these other things and get some of these other ones set up. So, all right. That's the lab. That's the setup. I'm going to go ahead and drop here. This is the recording for Unit 7, and then I will be on a little later to do the recording for Unit 8. I appreciate all of you guys coming by, and I will see some of you here a little later. Take care.